Hello everyone, today we want to unpack a massive stack of research from World Bank, maybe McKinsey, ARK Investment, the World Economic Forum, and Tech Radar to figure out what day-to-day future of our work is going to look like. By the year 2030, humans are expected to become optional in 50% of new warehouse logistics operations. Not unnecessary everywhere, not erased from the economy completely, but optional in a huge share of new warehouse environments. That is a stunning phrase when you really sit with it. Humans, optional. It sounds like the beginning of an automation panic story, the kind of headline that makes people imagine dark warehouses running with no lights, no workers, no lunch breaks, no shift changes, just machines moving goods through a system while a few people check dashboards from somewhere else. And to be clear, that future is not impossible. In fact, parts of it are already emerging, but the deeper story is more complicated than robots are taking our jobs. The real story is that the global labor market is being restructured because of aging populations, shrinking workforces, AI agents, humanoid robots, and a massive mismatch between the work society needs done and the human labor available to do it. The crisis we are walking into may not be simple job scarcity. It may be something more precise and in some ways more dangerous: talent misallocation. In other words, the problem is not only that there will be fewer jobs or fewer workers. The problem is that we may have the wrong people doing the wrong tasks at the wrong time in history. Advanced economies are aging fast. Birth rates are not replacing the people aging out of the workforce. Healthcare systems need more support. Infrastructure needs maintenance. Manufacturing needs resilience. Logistics networks need speed. Elder care needs human presence. And yet, too much human labor is still trapped in repetitive paperwork, routine data entry, manual checking, repetitive physical tasks, and administrative work that increasingly can be handled by software agents or machines. If society has fewer working-age adults, it cannot afford to waste human capital on work that machines can do faster, cheaper, and at greater scale. That is the deeper economic pressure behind this shift. This is why the future of work is starting to look less like a traditional human-only workforce and more like a three-part partnership: humans, AI agents, and humanoid robots. Humans bring judgment, empathy, accountability, creativity, social intelligence, and strategic decision-making. AI agents handle digital cognitive workflows: planning, drafting, analyzing, summarizing, validating, organizing, and coordinating software-based tasks. Humanoid robots bring the physical layer, the ability to move through human-designed spaces and perform tasks in warehouses, factories, hospitals, homes, and logistics environments. Once you see the future through that three-part structure, the conversation changes. This is not just about automation replacing workers. It is about a new operating model for the economy, where machines absorb more of the routine digital and physical work, and humans are pushed toward oversight, judgment, relationship building, and complex problem solving. The first part of this new structure is the software brain, Agentic AI. Most people already understand generative AI at a basic level. You type a prompt, and the model writes an email, summarizes a document, creates an outline, drafts a script, or generates an image. But Agentic AI goes beyond that. Instead of simply responding to one prompt, an agentic system can take a high-level goal, break it into smaller tasks, use tools, check its own work, correct mistakes, and continue through a workflow with less constant human supervision. A standard AI model might write a report when you ask for one. An agentic workflow might plan the report, gather the information, organize the sources, draft the sections, check the claims against the original data, revise weak areas, and then hand the final version to a human expert for review. That is a very different level of productivity. The cost curve behind this is staggering. The cost of processing large amounts of language has collapsed in a very short period of time. What used to cost real money now costs fractions of a cent. At the same time, model capability has improved dramatically. AI systems have moved from basic prediction and text generation toward stronger reasoning, better mathematical performance, more advanced scientific benchmarks, and more useful workflow execution. When high-level cognitive processing becomes extremely cheap, companies can start chaining specialized AI agents together the way a business chains human teams together. One AI agent plans, another structures data, another drafts, another validates, another revises, another prepares the final output for human approval. The result is not one digital assistant, it is a digital workforce. One of the clearest examples is in complex clinical documentation. Imagine a pharmaceutical company running a major clinical study. In the traditional model, huge teams of humans spend enormous amounts of time organizing study parameters, mapping timelines, preparing regulatory documents, cleaning messy data, drafting reports, cross-checking claims, and revising final submissions. In an agentic workflow, that process becomes a relay race between specialized models and human experts. A planning agent analyzes the study parameters and builds the first structure. A human medical writer steps in where judgment, regulatory communication, and accountability matter most. Then a data mapping agent organizes the messy clinical data. A report drafting agent creates a first full draft. A validation agent checks claims against source data to reduce hallucinations and factual errors. Then the human expert returns to review, apply clinical judgment, and handle nuance. If the human reviewer says a section needs to be reframed for a specific regulator, another agent can revise the draft automatically. A useful way to think about this is the high-end kitchen analogy. The AI agents are the prep cooks working in the back. They chop the vegetables, prepare the sauces, measure the ingredients, clean the workspace, and handle the repetitive but essential foundation of the meal. The human worker becomes the executive chef. The human tastes the sauce, adjusts the seasoning, decides what matters, catches subtle problems, and makes the final call before the plate goes out to the customer. The chef is not chopping every onion anymore, but the meal still does not leave the kitchen without human judgment. That is the shift. The machine provides scale, speed, and raw processing power. The human provides meaning, accountability, context, and final quality control. But there is one major limitation. A software agent can write a sophisticated report, analyze legal documents, summarize financial data, or help plan a business strategy. But it cannot hand you a cup of coffee. It cannot unload a dishwasher. It cannot move a pallet in a warehouse. It cannot stock shelves, lift boxes, carry equipment, or physically assist in elder care. That is where the second part of the new workforce comes in, humanoid robots. If AI agents are the digital workers moving through software, humanoid robots are the physical workers designed to move through the real world. They are being built to operate in environments that were designed around the human body. Kitchens, warehouses, hospitals, factories, offices, hallways, stairs, shelves, tools, handles, doors, carts, and equipment. The reason the humanoid form matters is not just because people are fascinated by machines that look like us. It matters because the world is already shaped around us. Doors are human-sized. Stairs are made for legs. Cabinets are built for arms and hands. Tools are made for fingers. Warehouse aisles are designed for people and forklifts. Hospital rooms are organized around human movement. Homes are full of objects placed at human reach. If a robot can use the same spaces, tools, and pathways that humans already use, companies do not need to rebuild the entire physical world around the machine. The robot adapts to the environment instead of forcing the environment to adapt to the robot. Economically, that is powerful. The challenge is that physical intelligence is incredibly hard. Something as simple as unloading a dishwasher is easy for a person, but extremely difficult for a machine. A human sees a mug, reaches around an open door, adjusts grip pressure instantly, feels the weight, senses the friction, avoids bumping the cabinet, and places the item on a shelf without thinking. A robot has to process camera data, depth perception, spatial mapping, object recognition, joint movement, force, torque, balance, and grip pressure all at once. It has to know how hard to hold the mug so it does not drop it or crush it. It has to understand that a ceramic mug, a plastic cup, a knife, a plate, and a glass bowl all require different handling. For humans, that is muscle memory. For robots, it is a major engineering problem. This is why robotic hands and manipulation are such a critical part of the humanoid race. Walking on two legs is difficult, but building a robotic hand that can gently hold an egg and then grip a heavy industrial tool is even more difficult. Physical dexterity is one of the hardest frontiers in robotics because the real world is full of variation. Every object is different, every surface is different, every angle is different, every task has exceptions. That is why humanoid robots have seemed for a long time like something that would stay in the laboratory. But that assumption may be changing faster than expected because humanoid robots have one advantage over self-driving cars: error tolerance. Self-driving cars operate in a very low error environment. A vehicle moving at highway speed cannot afford to make many mistakes. If an autonomous car misjudges a situation for even a second, the result can be catastrophic. A 2-ton machine moving at 60 miles per hour has almost no margin for error. That is one reason autonomous vehicles have taken longer than many people expected to scale broadly. But a humanoid robot walking through a warehouse or a kitchen has a different risk profile. If it drops a coffee mug, that is a mess. If it misplaces a package, that is an operational issue. If it moves too slowly, that is a productivity problem. Many of these failures are costly, but they are not the same as a fatal crash on a freeway. That higher error tolerance means developers can deploy, test, learn, and improve humanoids in controlled commercial environments faster than many autonomous vehicle systems can be deployed on public roads. And that brings us back to the forecast that humans may become optional in 50% of new warehouse logistics operations by 2030. Warehouses are one of the most obvious early environments for this shift because they combine digital coordination with repetitive physical movement. Goods need to be received, sorted, moved, picked, packed, scanned, stacked, and shipped. AI agents can coordinate inventory, routing, scheduling, demand forecasting, and workflow optimization. Robots can handle the physical movement. Humans remain in the loop to supervise, troubleshoot, maintain systems, handle exceptions, manage safety, and make decisions when the automated system reaches its limits. The warehouse does not necessarily become human-free, it becomes human-light, and the humans who remain are not simply carrying boxes, they are orchestrating systems. This is where the future of work becomes very personal for anyone listening. If AI agents can handle routine cognitive prep work and humanoid robots can handle repetitive physical tasks, what is left for human workers? The old automation story focused mainly on blue-collar labor. The fear was that machines would replace factory workers, warehouse workers, and manual laborers. But today's AI boom changes that story. The tasks most exposed to generative and agentic AI are often non-routine cognitive tasks. Finance, accounting, legal research, software development, analysis, marketing, documentation, reporting, and administrative coordination. These are white-collar professions built around digital information. And digital information is exactly where AI is strongest. That creates understandable fear for knowledge workers. People spent years earning degrees, building careers, mastering software tools, writing reports, preparing spreadsheets, analyzing documents, and learning how to move information through organizations. Now, the machine can do more of that work faster and cheaper. But again, the deeper issue is not simply replacement, it is reallocation. If the workforce is shrinking and society has major shortages in healthcare, elder care, infrastructure, skilled trades, physical maintenance, education, and human-centered services, then AI's role may be to remove routine cognitive burden so human workers can move toward higher value judgment and more human-intensive work. The danger is that not everyone will transition smoothly. The opportunity is that those who adapt may become far more productive. This is why the executive chef analogy matters so much. A white-collar worker who used to spend hours building a weekly financial spreadsheet may no longer be valued mainly for assembling the spreadsheet. The AI can do that. The worker becomes valuable for interpreting what the numbers mean, identifying risk, explaining trade-offs, recommending action, and communicating the story to leadership. A legal professional may spend less time manually summarizing discovery and more time shaping the argument, understanding the judge, advising the client, and choosing the strategy. A marketer may spend less time generating first drafts and more time understanding the audience, positioning the message, and deciding what will actually move people. In other words, the worker is forced upward, from data processor to strategist, from task performer to system manager, from manual producer to quality controller. That sounds positive, but it also creates friction. Not every worker wants to become a strategist. Not every organization knows how to train people for that shift. Not every employee has the confidence, communication skill, judgment, or adaptability required to manage AI systems. The premium on critical thinking, complex communication, ethical judgment, and adaptable decision-making is rising. The market value of routine data processing is falling. That means the future job market may not simply divide people into employed and unemployed. It may divide people into those who can manage machine intelligence and those whose work is managed by it. The same shift is visible in manufacturing. Companies are investing in reshoring, bringing production closer to home after years of relying on fragile global supply chains. But reshoring does not necessarily mean a return to the old factory job model. A company may build a new domestic facility, but instead of hiring thousands of manual workers to perform repetitive physical tasks, it may use robotics and automated systems for the heavy lifting, while hiring humans to supervise, maintain, troubleshoot, and optimize the systems. The factory comes back, but the old jobs do not always come back with it. What comes back is a more automated, more technical, more capital-intensive version of manufacturing. Now, if you live in a wealthy, advanced economy with access to these tools, this can look like a productivity boom. But globally, the picture is uneven. There is a major difference between advancing frontier AI and adopting AI. Advancing frontier AI means building the next massive model from scratch. That requires billions of dollars, elite engineering talent, massive data centers, huge amounts of electricity, specialized chips, and deep capital markets. Only a handful of companies and countries can compete at that level, mainly in places like the United States and China. Most low and middle income countries are priced out of the frontier model building race. But adoption is different. To adopt AI, a user may only need a smartphone, internet access, and the ability to type or speak in plain language. That is why AI adoption is spreading so quickly in many middle-income countries. Users in countries like India, Brazil, Indonesia, and the Philippines are already integrating generative tools into daily workflows at significant levels. In some cases, usage appears large relative to GDP and electricity consumption. That tells us something important. People do not need to build the frontier model to benefit from the model. They can adopt it, adapt it, and use it to accelerate their own work. But there is a major limitation: language and culture. Many frontier AI models are trained heavily on English language internet data. That creates problems for communities whose languages are underrepresented in the training data. For example, Hausa is spoken by tens of millions of people across Nigeria and West Africa, yet major language models may struggle badly with it because the training data is limited. If an AI model cannot understand your language, your grammar, your idioms, your cultural context, or your local reality, it cannot function as a reliable coworker in medicine, agriculture, education, law, business, or public services. A model that performs brilliantly in English may fail in a local setting where the language data is thin. That is why many developing regions are looking toward localized AI. Instead of relying entirely on massive foreign models, local engineers can fine-tune smaller open-source models on local languages, local documents, local laws, local agricultural conditions, local health information, and local cultural patterns. These smaller models may not be as powerful as the largest frontier systems, but they can be more useful in specific contexts. They may also run with fewer computing resources, sometimes even on local devices or lower-cost infrastructure. That matters in areas where broadband is unreliable, cloud access is expensive, and electricity is inconsistent. Foundational infrastructure still matters. Reliable electricity matters. Affordable internet matters. Digital identity systems matter. E-government portals matter. Telecommunications matter. Data governance matters. Education matters. If a country lacks the basic infrastructure to support digital systems, AI alone will not magically create transformation. Technology is cumulative. You can sometimes skip a generation of infrastructure, but you cannot skip all infrastructure. Local AI models may help, but they still need devices, electricity, connectivity, training, institutions, and trust. So the global AI divide will not only be about who has the smartest model, it will also be about who has the infrastructure to use AI at scale. So when we bring all these threads together, the future of work does not look like a simple battle between humans and machines. It looks like the emergence of a new workforce architecture. In the digital realm, specialized AI agents handle planning, drafting, research, data structuring, validation, coordination, and workflow execution. In the physical realm, humanoid robots and other automated systems handle repetitive movement, logistics, heavy lifting, warehouse tasks, and eventually more complex household and care-related work. And in the human realm, people provide oversight, judgment, empathy, ethical reasoning, communication, creativity, and strategic direction. The human worker becomes the anchor of the system. The machines provide speed and scale. The human provides purpose and accountability. That is the central shift. The future does not necessarily remove humans from work entirely, but it does change where humans sit in the workflow. In the past, many humans were the labor layer. They performed the task. In the future, more humans may become the management layer. They supervise the agents, audit the outputs, guide the robots, interpret the results, handle the exceptions, and decide what is acceptable. The value moves from doing every step manually to knowing how to direct the system and judge the outcome. That means the most valuable professional skill of the next decade may not be a single technical skill. It may not be one coding language, one software platform, one spreadsheet technique, or one certification. Those things can still matter, but the deeper skill may be the ability to manage non-human intelligence. Can you give AI agents clear goals? Can you evaluate their output? Can you catch errors? Can you communicate with automated systems? Can you understand where the machine is strong and where it is weak? Can you combine human judgment with machine speed? Can you supervise a synthetic team? That may become one of the most important career questions of the next era. Think again about that warehouse where humans are 50% optional. The humans who remain are not simply carrying boxes from one side of the building to another. They are monitoring flows, handling exceptions, managing robots, interpreting alerts, coordinating systems, maintaining safety, and making judgment calls when automation hits uncertainty. The same pattern may spread into offices, hospitals, factories, logistics networks, creative studios, legal teams, finance departments, and small businesses. The worker of the future may not compete by being faster than the machine. The worker of the future may compete by being better at directing the machine. So the question is not simply, is AI coming to take your job? That question is too small. The better question is, what part of your job is routine enough for AI or robotics to absorb, and what part of your work depends on uniquely human judgment? Because that is where your future value is likely to concentrate. If your work is mainly repetitive information processing, the pressure is coming fast. If your work requires trust, empathy, nuance, leadership, persuasion, physical dexterity in unpredictable environments, ethical judgment, or strategic thinking, your value may rise, but only if you learn how to work with the machines instead of ignoring them. The future of work is not waiting for permission. AI agents are already entering the digital workplace. Robotics is moving deeper into logistics and manufacturing. Humanoid systems are learning to operate in human-designed environments. Demographics are forcing economies to rethink how labor is used. Developing nations are adopting AI quickly while still facing infrastructure constraints. And workers everywhere are being pushed toward a new role: less task execution, more system orchestration. That may sound intimidating, but it also creates an opening. If machines take over more of the repetitive work, humans have a chance to move toward the work that actually requires humanity: judgment, care, creativity, leadership, communication, and responsibility. But that future is not automatic. It has to be built. Workers have to adapt, companies have to retrain, governments have to invest in infrastructure and education. And individuals have to ask themselves honestly, am I preparing for the old job market, or am I preparing to manage the new one? Because the next economy may not ask whether you can do everything yourself. It may ask whether you can lead a team that includes humans, AI agents, and robots. It may ask whether you can be the executive chef in a kitchen full of digital prep cooks and mechanical assistants. It may ask whether you can bring purpose, quality, and judgment to systems that are faster than you, cheaper than you, and available around the clock. So as you think about the future of your career, do not only ask whether AI is coming, it is already here. Do not only ask whether robots are coming, they are already moving from labs into warehouses, factories, and real-world environments. Ask the more important question: are you ready to become the boss of a synthetic team? Because in the future of work, the most valuable human may not be the one doing every task manually. It may be the one who knows how to direct the machines, audit the results, communicate the meaning, and take responsibility for the final outcome. That is the real future of work. Not human versus machine, human with machine, human above machine, human accountable for machine. And the people who understand that shift early may be the ones best positioned to thrive in the economy that comes next.